In this series of lectures, we are going to talk about polymorphism. Now, polymorphism builds directly on the concepts of inheritance, so it's really important to make sure you have a good, strong understanding of inheritance before moving on to the information about polymorphism. If you need to brush up on the ideas about inheritance, you should do so before continuing on with the lectures on polymorphism, again because these topics, the topic of polymorphism builds directly on inheritance, so please make sure you have a good, strong understanding of that first. And of course, all of these topics build upon your strong understanding of class and object design. So if you need to go back and review any of that, do so as well before beginning this next topic of polymorphism. So polymorphism relates to bindings. Now, typically when we invoke a method, we do so through an invoking object, right? We have some object, my object, and then we invoke a method, perhaps called do something, by using the dot operator. So we say my object dot do something. Now, when we have this line of code and we run the program, at some point in time, this invocation, so this line of code, is bound to the definition of the method that's being invoked. So at some point, we say that this line of code, again, is connected to the method that it's invoking. So somewhere where we have our method declaration, like our method header, and all of the implementation of the method, this method implementation is connected to the invoking of the method. Those two things are bound together. The invoking of the method is bound to the method definition. Now, if that happened at compile time, so if when we compiled our code, if the invoking of the method was linked to the definition of the method, then that means that that line of code would happen the same way every single time it was invoked, every single time it was run. Because at compile time, we'd figure out what method to link it to bind it to. We'd link them up, and then when we run the code, it would run the same way every time. But Java doesn't do binding at compile time. It defers that binding, it waits, and it does the binding at runtime. This is called late binding, or also called dynamic binding. And what this allows is it allows for greater flexibility. It means that one single line of code can actually invoke different methods at different times when you run the program. So again, if you did this binding at compile time, that one line of code would execute the same every time you ran the program. But in Java, because we use runtime, dynamic, or late binding, all different ways to refer to the same idea, that one line of code can have different executions at different points in time. And that's what polymorphism means. It means having many forms. So a polymorphic reference is a variable that can have different types of objects at different points in time. And then the method that's invoked to that polymorphic reference, again, can change from one invocation to the next. Now in Java, all of our object references are potentially polymorphic. It means that any object variable that we have can have multiple forms. It can have different forms. And depending on that form, the methods invoked on that object could be different at different points in time. So that's sort of the theoretical definitions, but let's take a look at an example because I think that's the best way to really understand what's going on. So to think about this, we need to know that for our object references, we can declare an object to be of a type that's higher up on the inheritance hierarchy, but then instantiate that object to be of any compatible type, which means any type lower on the hierarchy. So let's go back and look at our employee classes that we wrote when we were talking about inheritance. So we had a parent class called employee that was described by a name, ID, phone, and status. We had status is an enumerated type that we defined in the employee class. We have a couple different constructors that allow the user to create an employee object by specifying the name, ID, phone, and status, or by using the default value for phone and thus only specifying the name, ID, and status, or using the default value for both phone and status and thus only specifying the name and ID. We then have our getters and setters, a toString method, and then we added a couple class-specific methods, the pay method, the review method, and the benefits method. Pay method just prints out that the employee is being paid. Review prints out that we're conducting a review of that employee. The benefits checks the employee's status, and only if that status is associated with getting benefits do we process the benefits for that employee. And then of course we also wrote an equals method. Now we had a couple child classes. We have salaried paid employee, which extends employee because a salaried paid employee is an employee. They're just a specific kind. We added an additional instance data variable salary that's associated with the child objects. We have two different constructors that allow someone to set up a salaried paid employee by specifying all the information, including name, ID, phone, status, and the salary, or one that allows someone to use the default phone and status and only specify the name, ID, and salary. We have our getters and setters for the child variable that we added of salary. We overrode the toString, but we invoked the parent version first and then added on the salary information. We decided to override the equals method so that we could compare based on everything we wanted to compare in the parent class, which we do by saying super.equals, but then we also wanted to compare the salary, so we added on that requirement. We overrode the pay method because we actually wanted to say, well, we really want to print out that the salary is being paid based on this salary. I'm sorry, that the employee is being paid based on this salary. So we changed the inherited version and replaced it with this new version. And then I actually just added a method called vacation. Perhaps only our salaried employees get paid vacation days, so we'd be able to process vacation days for a salaried employee. So I added this method. Note that this is not an overridden method because it doesn't exist in the parent class of employee, it only exists in the child class of vacation. We then have our hourly paid employee class. This also extends employee. An hourly paid employee is an employee. We have a similar collection of constructors that allow us to create an hourly paid employee using sending in different information. We added the instance data variable of an hourly rate to this class, and we also have a default hourly rate, perhaps like the minimum wage. So one way that we can initialize an hourly paid employee is by not specifying an hourly rate, and then the default hourly rate will be used. We have our getters and setters. Our toString, again overridden, but we do invoke the parent version before adding on to it. And then we again overrode the pay method so that we could print out that we're paying at an hourly rate. And I again added a new method here, personal time. Perhaps our hourly employees, they don't get vacation, but they get personal time, and so we could process that for them. And then we have our unpaid employees, which extend employees. So again, an unpaid employee is an employee. You can think about this perhaps like an intern. I didn't add on any additional instance data variables, so we just describe an unpaid employee by their name and ID. We overrode the pay method. We also overrode the review method because even though in our salaried paid employee and in our hourly and paid employee classes, we just inherited the version from employee because that made sense. But if it doesn't make sense for this class, then we override it. And then we also overrided the benefits method because the inherited version didn't make sense for this class. So those are the inheritance classes that we previously wrote: 1 parent class, 3 child classes. So thinking about how we can use these classes as an example of polymorphism, as I mentioned on the previous slide, you can declare a variable to be of a type high up in the inheritance hierarchy. You can declare it to be of that type, but then you can instantiate it to be of any lower type. So for us, the class that's high up is employee. So we could declare an object as type employee. But we don't have to instantiate it as an employee. We can instantiate it as an object of any compatible type. And what that means is any class lower on the inheritance tree. So I'm allowed to declare an object of type employee and instantiate it as a salaried paid employee, or declare an object of type employee and instantiate it as an object of hourly paid employee, or declare it as employee and instantiate it as unpaid employee. So all of these are legal statements. We can declare as a type higher up the tree and instantiate as a type lower down the tree. Now, why would I ever want to do this? Well, let's say we were keeping track of a whole list of employees in lots of different departments that have all different kinds of employee objects. Well, we only want one list, we want one array. So the type of that array has to be employee, an employee array, or an array list that holds employees, because we want that's the commonality. We want to hold a bunch of employees in this array, but maybe some of those employees are salaried, and maybe some of those employees are hourly, and maybe some of those employees are unpaid. We want to be able to keep them all in the same list because we want to keep track of all our employees at once, but each one of those employees might be a different type. So Java allows us to do this. It allows us to say, well, the declared type here is employee, but as long as you give me a compatible type, meaning someone lower down on the inheritance tree, well, hey, sure, you can instantiate this as a more specific kind. And this makes sense if you think about it, because a salaried paid employee is an employee. So here we can say employee E1 or employee E is going to be this specific kind of employee. And employee E2 is going to be this different specific kind of employee. And employee E3 is going to be this other specific kind of employee. So this is again where that is a relationship is really important, because it makes sense that we could instantiate an employee object of a more specific kind as long as that is a relationship holds true. So it's actually the case that all of our object references really don't have just a single type. They have two types. They have a declared type and they have an actual type. So the declared type is the one that we get in the declaration statement. So when we declare our variable and we specify the type and the name, that's the declared type. And the declared type is determined at compile time. So when you compile your code, all the compiler knows about is the declared type. And that declared type is used to control which methods are allowed to be invoked. So if you want to invoke a method on a variable, that method must exist in the declared class. Otherwise, you won't be able to compile your code. So all the compiler knows is declared type, declared type, declared type. That's it. But our objects also have an actual type. And this is the real type of the object. It's based on what constructor you invoke. It's based on the actual type you use to create the variable. And this is not determined at compile time, but it's actually determined at runtime. And the actual type is in charge of which version of a method is invoked. So the declared type controls whether or not you're even allowed to invoke a method, but the actual type determines which version of that method is invoked. So let's see how this works. So let's say, for example, we have employee E1 or is a salaried employee, salary paid employee, mark monies, same data we used before, with this ID and this salary. And then we've got we're going to change the declared type from the example we used previously so that these are both declared as employee types. And we've got our hourly paid employee, Hank hourly, our hourly employee mini minimum, and our unpaid employee Irvy the intern. Okay, so here we have four variables, four object references whose declared type is all employee. So the declared type of E1, E2, E3, and E4 is the same, it's employee. But the actual type differs. The actual type of E1 is a salary paid employee. The actual type of E2 is an hourly paid employee. Same thing for E3. And the actual type of E4 is an unpaid employee. So these objects all have the same declared type, but different actual types. Okay, so what happens if we invoke the pay method on E1 or on E4? Let's run the class and see. So the E1, the actual type, is a salaried paid employee, and when we run this code, we see that we get paying the salary of 5,000 divided by 52. That's the salaried paid employee version of pay. And when we invoke it on E4, we get this employee is not paid. That's the unpaid employee version of pay. So because E1's actual type is salary paid employee, we get the right version of the pay method. We get the version associated with this class. And because E4 is an unpaid employee, we get the right version of the pay method. We get the version associated with this class. So at runtime, Java says, okay, tell me what the actual type is of object E1, and then I will use that to figure out which version of the pay method to invoke. So even though the declared type is E1, we don't invoke the pay method from employee. Even though the declared type is employee, we don't invoke the pay method from the employee class. We invoke it from the salaried paid employee class. So the version of the method that is invoked is based on the actual type. Okay, so not the declared type, but the actual type. That means that this invokes pay from salaried paid employee, and this invokes pay from unpaid employee, which is really what we want, right? We want the right version. We wrote a version in unpaid employee, and we want that method of pay to be called on all unpaid employee objects. And same thing for all the other classes. We want the right version to be called, and Java does just that. It uses the actual type to figure out which version to call, and then that's the one that it calls. And that's what we mean by a polymorphic reference, because E1, because its declared type is employee, in theory, this could refer to a salaried paid employee, an hourly paid employee, an unpaid employee. So we might not know what version of pay is going to be invoked. It might be invoked on a salaried paid employee at one point in the program and an unpaid employee in another, because any of those are compatible types with employee. Okay. So that's what the actual type is used for. It's used to determine which version of a method gets invoked. But the declared type does count for something too, because the declared type means that the method has to exist in this class. So because there's a pay method in the employee class, that's the only reason we're allowed to invoke pay at all. If, for example, we've tried to invoke e1.vacation, because there is a vacation method in the salaried paid employee class, we get a compiler error. Because the compiler doesn't know anything about the actual type. All the compiler knows is the declared type. So in order to get past the compiler, this method must exist in the declared type of this object. The declared type is employee, and there is no vacation method in the employee class, so we cannot invoke this method. Okay? So the compiler requires that the method exists in the declared type. So we cannot do this because employee has no vacation method. So this is not allowed. So each piece of information counts for something. The declared type determines whether or not you can compile, and basically it means that that method must exist in the declared class, but then at runtime we use the actual type to figure out which version is invoked. So we're allowed to invoke pay because it exists in employee, but at runtime we don't use the employee version of pay, we use the salaried paid employee version of pay. Okay, so you do need to know about both pieces, both types. The declared type determines what is allowed to be invoked, and the actual type determines which version of the method is actually run.